Good morning. So much for joining us here today at the Mote Sea Show. My name is Ross, and I'm coming to you live from Mote Marine Laboratory all the way down in Sarasota, Florida. Now, I am so excited to be connecting with these students and future ocean scientists from all over the world this morning because we have a very exciting topic. We're going to be learning about ocean technology, tracking, tagging, monitoring. We're going to meet some amazing ocean scientists and see what they do, the research they have out in the field, what animals they study, and how they work with those animals both out in the ocean and back in our laboratory. Now, Mote Marine Laboratory is a very interesting institution because not only are we a world-famous scientific institution, but we are also a public aquarium, which is a really nice relationship because our scientists at our lab get to study the animals who live here at our aquarium, as well as the guests who get to visit our aquarium get to see science in action. Now, all of you future ocean scientists get to see some amazing science in action today when we meet our two guest experts. But before we meet these guest experts, I want to see what you know about ocean tracking and tagging. So we're going to throw up a quick quiz question to see all of you future ocean scientists and what you're aware of regarding marine technology. So, when we study these animals, when we track and tag and monitor these animals, why do we do that? What is the point of using this tracking, tagging technology for these ocean species? So, you have three different options up on your screen. So, all you teachers out there, all of you facilitators, get a good poll of your students and start to fill in these answers on this online poll, this online survey. Now, while these questions are going, we're going to turn it over to our PR manager, Stephanie, and she's going to let us know some contemporary, up-to-date marine science news in our current events section. So we will be right back to answer this question.
News with Stephanie Kettle.
Hi, I'm Stephanie, and here's the news that's making waves. Mote Marine Laboratory scientists are excited to partner with Scigirls for the launch of their 5th season. Scigirls is an Emmy Award-winning PBS Kids television show, website, and educational program that draws on cutting-edge research to help girls explore science, technology, engineering, and math careers. During the first episode, Scigirls from Sarasota, Florida meet with the same Mote scientists you're going to see today. They learn about tracking, tagging, coding, and the technology used in Eagle Ray research. This partnership was made possible through the National Girls Collaborative Project, a project that features hundreds of professional women in STEM that act as mentors and role models. Tune in on December 12th, 2019 to watch Scigirls Season 5, Episode 1, High Tech Tide on PBS Kids. From Sarasota to Spain, our scientists are all over the world presenting marine mammal research. Researchers from Mote Marine Laboratory and Chicago Zoological Society's Sarasota Dolphin Research Program will attend the World Marine Mammal Conference in Barcelona, Spain this December. The conference is co-sponsored by the Society for Marine Mammalogy and the European Cetacean Society. Over 2,000 attendees are coming from more than 95 countries, proving the theme for this year, Together for Science and Conservation. Scientists will have the opportunity to present research to their colleagues from around the globe, attend workshops, and create new collaborations to improve the world for marine mammals. Many people love seafood, but that can sometimes lead to overfishing. So this November, Mote Marine Laboratory hosted the 6th International Symposium on Fisheries Ecology, Stock Enhancement, and Sea Ranching to look at the causes and effects of increased demand for seafood. The goal is to come up with innovative ways to meet higher demands. Scientists from around the world will collaborate on strategies to restore fishery populations. Topics include sea ranching and fish farming, improving habitats by building artificial reefs, and much more. And all this is happening just in time for World Fisheries Day on November 21st. Visit mote.org to find out more about this seafood-saving science.
Well, thank you so much, Stephanie. That was very informative. Now, if you notice, I am joined by two amazing marine scientists, Dr. Krystan Wilkinson and Kim Bassos Hull. And now they are absolutely fantastic marine technology experts, and they will be teaching all of us about their amazing oceanic exploits. Now, going back to that quiz question, there were three really good options, but which is the correct one? So what do you think? Tell us the correct answer.
Well, we tag ocean animals, and a tag emits a sound that we can detect with receivers out in the water. So it's Z, right?
Fantastic. So not only do these tags collect sound,
Yep.
but it turns out the correct answer is all of the above. That's absolutely right. So our marine technology experts do get to use lots of different types of tags to study lots of different types of ocean animals, which is our perfect transition into learning more about what you do on a daily life. So tell me more about your job. Tell me who you are and what your amazing job entails.
Well, I'm a researcher with the Chicago Zoological Society Sarasota Dolphin Research Program, and I'm also an adjunct scientist with Mote Marine Laboratory Sharks and Rays Conservation Research Program.
And Kim Bassos Hull. I am a senior biologist here at Mote Marine Laboratory. I also study dolphin populations and work with the Sarasota Dolphin Research Program, and here with the Sharks and Rays Conservation Research Program. So part of the things that we do with the Sharks and Rays Conservation Research Program here is we study the biology, ecology, and health of populations of sharks and rays here. And some of my colleagues, for instance, study shark populations. And in fact, they've been tagging some of the biggest sharks in the sea, such as whale sharks, and check out osearch.org for some of the cool research they're doing tagging white sharks. So if you want to see where white sharks are tracking. So my main focus has been studying the ray populations in our local waters, such as eagle rays and manta rays, some of the largest rays in the sea, and devil rays.
So it sounds like you have a wide array of scientific interests. Terrible, absolutely.
Everyone.
Now, looking at these animals out in their ocean habitat, you mentioned OSearch goes out in this big research vessel, tracks and tags these huge animals, great whites, hammerheads, whale sharks. Now, you're a little more local, so you study eagle rays, you study devil rays. So how do you do that? What does that look like in the day of a life of a tracking, tagging scientist?
Right. Well, we want to tag animals because it's really important for us to understand their movements and what habitats are important for them so that they can feed and give birth. These are really important so we can develop conservation plans to protect these species. And it also gives us some important information when there's environmental events such as hurricanes and red tides, which are harmful algal blooms that can cause irritation to animals that swim in the ocean. How do they respond to that? So these are some of the questions that tagging animals can help us answer.
That is so cool. Now, I know that you're bouncing all around the world. You're studying different animals in different habitats. So where have you been? What does the ocean habitat of a marine scientist look like?
It's quite wide. Kim and I have worked with research colleagues in Mexico, both on the Gulf of Mexico side as well as the Caribbean side, as well as Cuba and the Bahamas. And in these areas, we're working with our colleagues to understand the populations in the local environment as well as more of a regional scale. And then we're also engaging with the local communities in these areas so that they can send their sightings of a spotted eagle ray back to us. And using photo identification, we can identify individuals based on their unique spot patterns so we can see movement between the areas using photo ID. So here's a spotted eagle ray, and this little guy has a unique spot pattern, and its buddy might have a different spot pattern, so we can tell them apart.
That is so cool. So just like humans, our freckles are different on every face. So these eagle rays have their own unique spot pattern. So when they're ricocheting around the Gulf of Mexico, between Cuba, Mexico, Florida, our scientists like Kim and Krystan get to look at where these animals are going and what habitats we need to protect in order to make sure that their populations don't go south. Now, looking at these amazing animals, you have to capture them in order to tag them. How does that even work? How do you catch an eagle ray? Look how huge that thing is.
So we go out on our research vessel that has a tower so we can be really high up and look through the water column, and we can visually spot a spotted eagle ray. And once we do, we deploy a net around the eagle ray, and then our catch crew jumps in and scoops them up with a smaller net, and then we bring them on the boat where we have a live well or a big tank filled with water so the ray can be swimming around in the tank while we're doing our measurements, collecting our samples, and doing our tagging.
That is so cool. So this footage that's taking place on your screen right now, so what are you doing with this measuring tape? What are you doing with these vital signs? Why do we need to collect this data?
We're collecting a lot of this important data, such as measurements and blood samples, to look at the health of the animal, also life history, when are they sexually mature, things like that, because that's really important to establish population parameters and provide information to management for better conservation. And it's because these guys get impacted in fisheries in other countries that we're really interested in what's happening to populations and what can populations be, when populations can be sustainable or when they might be overfished.
Wow, that's so crazy. So you do this field research, you collect them in these big nets, you use the observation tower. That's so fantastic. But once you collect this data, once you collect these vitals, you have to tag them. So I am so excited that you brought a lot of technology with us today. So can you tell us a little bit more about some of the gear that you use? Now, while you're queuing up all of this gear, we're going to get ready for our next quiz question. So get ready, all you future ocean scientists out there, because one of the amazing tags that they brought with us today is called an acoustic tag. But that's a pretty big fancy science word. So I want to see if all you aspiring ocean technology experts out there can guess what an acoustic tag actually does. So we're going to queue up this next question. What is an acoustic tag? Is it X, a tag that plays music, Y, a tag that absorbs sound, or Z, a tag that transmits signals? So once again, use that polling feature. All of you teachers out there can be facilitating these answers. So what do we think it does? All right, it looks like Z's rolling in. Do we have any guesses for X or Y? No, it looks like we're all Z. So there's a lot of waves in the ocean, and some of those waves are sound waves. But now, we want to look at what these tags actually collect. So what's the correct answer, you two?
Z.
Fantastic. All right, so it is Z. It is a tag that transmits signals. So tell us more about what this acoustic tag does. And oh my gosh, you brought one. How cool is that?
Well, this is
The receiver.
Okay, great.
so right here. I have in my hand an acoustic tag. So I'm going to move this a little bit. There we go. Can we see it?
Perfect.
There we go.
There we go. Nice.
So this is the different sizes that we have of acoustic tags. We have these tags put out sounds that we attach these tags to the animals, and they actually put out sounds that are a unique pinging code. And then as these animals swim through the water, we have these acoustic receivers, which Krystan has one in her hand. So this is mounted to the sea floor, and as the ray swims by, and I think we have a graphic too that shows it. So this happens to be a shark that's tagged, but as it swings by, it pings, and that receiver picks up those sounds. And it says that this shark that we tagged maybe a couple months ago was here at this date and time. So all of that information comes into these receivers, and that we can download those at a later date and get all that kind of really cool information.
That is the coolest thing. So it's kind of like fish Marco Polo, right? So we get to see where these fish go, how often they visit. So then how often do you collect this data? What does it mean to go out, put this stuff at the very bottom of the ocean? How often do you get to do this?
Yeah, so we usually go out about twice a year and download the data. And the really cool thing is that the data that comes off of this is not only shared with the researchers here working at Mote, but it's shared with researchers working all over the Gulf of Mexico in a very collaborative way. So we even pick up animals that other researchers have tagged from the Keys or up the northern part of the Gulf of Mexico. We picked up all kinds of animals, and it's really, really cool.
That's amazing. So it's a big global stingray database, essentially.
Not only stingrays, but we pick up tarpon and snook and sawfish and other sharks. Even some sharks that were tagged over in the Bahamas swam into the Gulf of Mexico. So we're sharing this data, which is great.
That is so amazing. Okay, so you're sharing this collaborative data. You're using these acoustic tags, which is the coolest thing. But I remember that you mentioned that the acoustic tags aren't the only type of equipment you use. So what are some of the other tags? I heard you talk about spaghetti tags.
Yeah, well, spaghetti tags is like a little external tag, but we also do. If we want to get information, they're a little bit more expensive, but we can put a satellite tag on an animal. And if you have a big budget, you can put a satellite tag on. And one eagle ray that we tagged about 6 years ago, we put a satellite tag on her and learned all kinds of stuff. For instance, she dove to the bottom during the day, probably to feed, and spent more of her time at surface at night. And then she tracked all the way up to almost the Panhandle area and then turned around and went down towards Cuba. So we learned from the satellite tag that she spent a lot of time along the west coast of Florida, going north and almost down south past the Keys from the satellite tag.
Gosh, that is the coolest thing. So you said that they dive down really deep during the day, probably to feed, right? So what is on the menu for an eagle ray? How does that even work?
So we have some really cool. So this is an eagle ray skull that shows their teeth are modified into crushing plates. So these guys have the ability to take shells or mollusks and crush them up. And there's a variety of the local mollusk species. So eagle rays target some of our gastropod or snail species. And these are some examples. And then there's also our bivalves, the things that have two shells. Like this is a bivalve, and that's a clam. So we are able to tell what they're eating using sound, which is another really cool ability to detect what they're eating by listening to sounds in the ocean. These guys make some, loud sounds when they eat, turns out.
So it brings a whole new meaning to the word soundbite, right? Oh, terrible. Now, looking at the data you collect based on what they like to eat. So we're going to turn it over to our third quiz question. So this is more of a think, pair, share. So all of you aspiring ocean technology experts, turn to your partner and talk about, for a few seconds, what do you think we can learn from tagging animals? So obviously we can understand where they're going, what they're eating, but why do you think that's important? So what else can we learn? So talk to your partner, create some hypotheses, like all you good scientists out there, and then type your answers into the chat. All you teachers and facilitators can start to collect data on what your kids are thinking. Fantastic. So I see a lot of answers coming to the chat. Now, while all you future ocean scientists are typing in, we did get a question about, does this tagging of the animal actually hurt the animal? What does that look like?
Well, we've seen animals, it's very minimally invasive, and we attach the tag, and then the animal swims away very strong, and we continue to get detections from it. Cool. So we know that the animals are acting very similar. So yeah, I think it's a minimally invasive procedure. We use something called tonic immobility, which kind of puts them in a trance-like state, and then we're able to release them afterwards. If you ever hear you flip a shark upside down, and they kind of like, so they, it's very minimally invasive, and it doesn't hurt them.
And also these sharks and rays are cartilaginous, so similar material to our ears or our nose. And so the tagging is similar to us getting an ear piercing.
What a great comparison. So that's right. Sharks, skates, rays, these eagle rays, they have no bones in their body. So if you wiggle your nose or if you wiggle your ears, that's our cartilage, and that's what they're made out of. So just like getting your ears pierced, great comparison. I love that. Now we're getting a lot of answers rolling in, which is very exciting. So we can collect this data from these targeted animals. So what can we learn? How can this be moving towards conservation efforts?
Oh, well, so the information that comes in will tell us the times that the animals were here and present, so we can look at residency patterns. We can look at how often they're moving throughout the estuary, and if they're going inshore or offshore. by getting data from our colleagues that there's a larger array network in the Gulf of Mexico. Our one local one is called the Sarasota Coast Acoustic Network, which is SCAN is our term. And then as soon as our animals swim outside, there's a larger acoustic array network called ITAG. And this is receiver locations all over the Gulf of Mexico, and researchers share this data. From this data, we've learned some really incredible stuff, such as what times of year animals have gone north and south in the Gulf. It seems like our eagle rays are going north in the summer and then heading south in the winter, which is what a lot of snowbirds tend to do.
I was about to say, just like our vacationers.
So it might be that, we're learning that water temperature might be driving where these guys are moving. But it also might be the food and the food availability. And, and then we're starting to learn a little bit about red tide and how harmful algal blooms are impacting their movements.
Fantastic. So speaking of food availability, let's test all these future ocean technology experts with some acoustic monitoring of our own. So we have some snacks that we brought in, and we want to see how well all of you out there can use your acoustic monitoring abilities to see if you can study what our scientists study. So instead of learning about what an eagle ray eats, you're going to see if you can tell what we're eating. So we have 3 different snacks for you, and we have 3 different scientists. So we are going to look at potato or tortilla chips, an apple, or a carrot. So we are going to crunch into our microphones, and you're going to be able to guess, so in your polls and your chats, if you can guess which of us is eating which snack, which is exactly what Krystan and Kim do when they're looking at the different sounds the different shelled animals make when the eagle rays are eating them. So, get ready. What do you think Kim is eating? Here's the crunch. All right, fantastic. Now let's see what Krystan is eating. All right, and finally, what am I eating? All right, well, I finished chewing my bite.
Don't want to talk with your mouth full?
I'm about as graceful as an eagle ray. All right. No bones about it, right?
No.
But, terrible. All right, so it turns out we get a lot of guesses that are flooding in. So, Kim, what did you bite into?
I had an apple.
All right, so great acoustic monitoring there. Krystan, what did you eat?
I had the tortilla chips.
Delicious. And that means I had the baby carrot. So great job. So this is some of the equipment and skills that it takes to be an ocean researcher.
Yeah.
Now let's see. We're playing a really cool video right now where you can actually hear the eagle ray crunching.
Yeah. So this is we actually tested this with eagle rays in a tank, and we put in some clams and we put in some snails, and we listened to the sounds that the eagle rays made when they were eating the different types of prey, and we found that they spent a lot more time crunching to try to get the meat out of a clam than they did out of a snail. And so we were able to measure this scientifically in a tank, and so we're hoping to use this and answer that question out in the wild. For instance, like what where are they eating, and are they eating clams or are they eating snails out in our habitat?
That is such cool data. I guess it's really a reason to celebrate, right? Awful. All right, so we just got to meet some amazing scientists, and we got to see their research firsthand, and all of you scientists got to do some acoustic research as well on us. But there's a lot of future ocean scientists out there, and I bet they're wondering, how do they grow up to be a researcher like you? What are some opportunities, some experiences that they can do right now in order to get on the fast track to become a marine researcher?
Well, we had the great opportunity to bring in 3 local middle school aged girls to help us with analyzing some of our eagle ray data. This was part of the Scigirls episode. So tune in December and watch the episode High Tech Tides to find out their results. But their question was, what does how often are the rays here during times when we have red tide versus during time periods when we don't have red tide. And I don't want to give away their awesome results, so please tune in and check it out. But we do have a lot of other really exciting opportunities for students to get involved in our research, right, Kim?
Right, yeah, so we've actually involved some of our high school interns through our high school internship program. They've been able to come out on the research boat. They've helped us with testing out acoustic tags. They've helped us collect benthic prey. So we're studying not only the eagle rays, but what they're eating and what's available to them out in the bay. And we also take in college interns. So we do a very intensive 3-month internship. So we're doing education on opportunities on multiple levels. And lastly, we go out and we talk to the public through things like our Youth Ocean Conservation Summit. I did a Tag Your It acoustic workshop to show middle and high school students how we use this technology. So they got a hands-on opportunity to come into our awesome Youth Ocean Conservation Summit.
That is so cool. So you're never too young to start your track to become a marine scientist. Middle school, high school, college, there are internships and opportunities for scientists of all ages. Now we're actually going to cut to a really special clip for the promo of the next Scigirls episode featuring these two lovely scientists. So we're going to cue that up and get ready to enjoy when it launches in December.
Couldn't really hear.
So, how amazing is that? Fantastic. So we got to see some amazing scientists in action and some future ocean researchers. Now, the neat thing about our future ocean researcher program is that it can start with children as well as middle, high school, college interns of all levels. Which brings me to our amazing next expert. This is one of the most inspirational marine educators I've ever met. From New Zealand to Vermont, from Florida to Chicago, she is the go-to resource for environmental conservation education. So, oh my gosh, Julie, let's meet you and tell me what you're all about.
Well, it's so great to be here because I have to tell you, based on what you were just talking about, that I started my career as an intern here in 1994. And I really didn't know anything other than my parents said, hey, why don't you come down to Florida and intern at this really cool marine laboratory? And I said, sure. And little did I know I was going to be able to work alongside my heroes like Jeannie Clark and Randy Wells and all the people who are working so hard every day for ocean conservation. And it's just grown from there. And really, it's just, for me, it's always been about the opportunity to say yes, especially when it scares me, like going out and tagging sharks in the wild. That was a crazy experience, but one that I'm so glad I said yes to so many years ago.
The most inspirational. That is the coolest thing. So Julie's job is to celebrate marine conservation, to celebrate the oceans and the science and education that drives future change, which is a great transition into learning a little more about the Youth Ocean Conservation Summit. So can you tell us a little bit more about that and the fact that you're the keynote speaker for it?
Yeah, I'm really honored to be asked to be the keynote speaker this year because, again, that's where my heart is. It's really inspiring people of all ages to really follow their passion, their drive, and the change that they're supposed to make in the world. And really, one of the things I want to say from the beginning is I'm really passionate about the fact that everyone has a really unique way to make change. So your genius can be in art, it can be in writing, it can be in business, it could be in engineering. All these different facets can have science at its core, and we need all of you to work towards that goal for conservation. So that's what the Youth Ocean Conservation Summit is all about. It's bringing kids of all ages, 8 to 18, who really want to explore how they can take their skills, their genius, their talent, their niche, and really move the needle for conservation.
Animals have different roles in the environment, and conservationists have different roles in inspiring future generations. Now, that is so wonderful to hear that it is so interdisciplinary. So art, business, science, we're all working towards the same goal. So before we wrap up, I want to hear a little bit more about your job. So finish line leadership. So what do you get to do now? You've been all around the world. What's your current project?
Yeah, so I've spent the first 10 years of my career working inside zoos and aquariums. The second 10 years of my career working outside of them, helping some of them, but also working with clients of all types, like insurance companies. And last week I was 1,800 feet underground in a limestone mine. That was totally new for me. But now in the third phase of my career, I can take all those learnings and really take, quite simply, the lessons from the animals about how we can all be better leaders and make the change that we're supposed to make in the world. So my job is speaking to people, which is kind of crazy for someone who was once too shy to even come out on stage as a kindergartner. So you never know where your life will take you.
Well, I love that you're learning leadership answers from animals. That is such a cool comparison, which is a great transition into some literature that you brought with us today.
Yeah, I want to inspire all of you who are in school right now to realize that some of the ideas you have, you're never going to know when they'll come back to really spur you on to the next phase of your career. So what I'm holding is something I worked on in 1996, and this was my senior year thesis to really think about the leadership lessons from animals. So literally 23 years later, I'm still working on the same project, which is a good thing. Okay, it's a good thing, but 23 years later, I'm taking these ideas and growing them. And so keep those ideas, keep going, keep growing, and take notes along the way. Journal, because you never know when they come back.
That is the coolest thing. All right, so it looks like we're starting to wrap up. So we talked about the Youth Ocean Conservation Summit. We talked about Scigirls, very exciting, as well as some ocean technology and marine researchers. So I want to invite Kim and Krystan back on so we can do one last group finale. And while we're wrapping up, if you have any last-minute questions that you want to type into the chat box, while you're typing those, I want to plug one last resource for you as well. Unfortunately, we are starting to run out of time, but I do want to talk about our Flipgrid page. Now, Flipgrid is an awesome website that we've partnered with, where it's essentially a video voicemail service where you can leave a free video question and we will respond with a personalized video answer. So if you go to our ctrek.tv webpage and you look at the Ask feature, your students, your future ocean researchers, will be able to ask any Flipgrid question as long as it relates to marine science, and we can pass it directly on to our marine scientists here at Mote Marine Laboratory. Now, as these questions come in, I want to thank all of the amazing individuals that joined us here today. Kim, Krystan, Julie, we learned so much from you. Now, as we are winding down, please... All right, so I'm not sure where we broke off, but I was plugging our Flipgrid webpage. So our Flipgrid is that great video voicemail service. Feel free to leave any video questions on our Flipgrid page. We'll put the link in the chat for all of you future ocean scientists, as well as our C-Trek programs as well, where we can bring our scientists directly to your classrooms. So we are winding down. I want to thank all the amazing individuals that joined us here today. Kim, Krystan, Julie, we learned so much about eagle rays, technology, youth ocean conservation, and make sure you tune in for our Scigirls program in December. So once again, thank you so much. We'll have our final wave off. So let's send them off. Thank you so much. Once again, I'm Ross. We're joined by Kim, Krystan, and Julie. Thank you for joining us on the Mote Sea Show, and we hope to connect with all of you very soon. Bye, everyone.